Okay, hello. So this is the video for the second lesson of Unit 7. Just to kind of refresh your memory, Unit 7 is all about systems of linear equations. So what that means is a system is two equations. And if I ask you to solve the system, that means imagine if we were to draw out those two equations as lines on a graph, where would those two lines cross? So for lesson 1, we did the first method of solving a linear equation, which was I gave you the two equations, we put them into explicit form, and then we graphed them. And then once we graphed the two lines on the same graph, we saw where they crossed at that point, and that point was our answer. Okay. Lesson 2 is I'm showing you a different method to solve where we don't have to graph anymore. So lesson 2 is no graphing. It's called substitution, where we just essentially use algebra and our math skills to figure it out. So I have laid out here the first 3 steps, and for each example, I'm going to put each step in its little heading here so you know which step is which. So step number 1 is in either one of the equations, isolate either x or y. So step 1, you have a lot of options. You can pick either one of the equations you want, doesn't matter. And then say you were to pick this one, you get to choose to isolate either x or y. And remember, isolate means to get it all by itself. So I think I'm going to choose to number 2 here, and I'm going to choose to isolate x, because all I have to do here to isolate x, to get x all by itself, is to take the 2y and send it over, and then x would be by itself. So for step number 1, I'm choosing to isolate x in equation 2. Okay, so I take equation 2, x plus 2y equals 2 is my equation. To get x all by itself, I just have to take my positive 2y and send it over to the other side. But remember, when you send it over to the other side, you change the symbol. So I have x all by itself on the left side. Now on the right side, I have this 2 that was already there, but because I sent over a positive 2y, it's now going to become negative 2y. Okay, and there, it's isolated. So I've isolated x in one of my equations. Step 1 is already done. Okay, number 2, take the equation that is now isolated, so this guy right here, and substitute it into the other equation and solve. So step number 2 says take this one I just isolated and plug it into the other one we haven't used yet. So I'm going to plug x equals 2 minus 2y into the equation I haven't used yet, which is 1. So I'm taking what I just isolated and plugging it into the equation I haven't used yet. So I'm going to write down the equation that I'm dealing with, which is number 1, 3x plus 4y equals negative 4. Now, what I mean by plug this in is x equals 2 minus 2y. So x can be replaced with what it equals. So in this equation where you see an x, you're going to actually replace it with what x equals, 2 minus 2y. So 3, open bracket, instead of x, I have what x is equal to, 2 minus 2y. Close the bracket and then recopy the rest of the equation. And then it says to solve. So I'm going to simplify this. So this means I distribute that 3 into the bracket. So I get 6 minus 6y when I go 3 times 2 and then 3 times negative 2y. And I recopy the plus 4y equals negative 4. I can simplify these similar terms. They're both y terms. So instead of having negative 6y plus 4y, well, negative 6 plus 4 is just negative 2. So I have this 6 from out front here still, and then that becomes negative 2y equals negative 4. Now, what I mean by solve here is to solve for y. I want to figure out y equals what? I want to get y all by itself. So I have 6 minus 2y equals negative 4. This 2 is multiplied to the y, so we leave them till the very end. I have to get rid of this 6. So if I want to get rid of it, I just have to minus 6, because 6 minus 6 is 0, and it's gone. But once I do it to one side, I have to do it to the other side. So those are canceled. I still have negative 2y on the left-hand side, but now on the right, negative 4, take away 6 more, I'm at negative 10. And finally, because I have to get rid of this negative 2 that's multiplied to my y, to undo a multiplication, I do division by exactly what I want to get rid of. So by dividing by negative 2, those cancel. I get y all by itself. Negative 10 divided by negative 2 becomes positive 5. So there you go. I have solved for y. Okay. So remember, your solution is always a point. Okay. Like x comma y, coordinates on a graph. So I know my y value is 5. So step 3 is to take the variable you just solved for. So the variable I just solved for is y, and plug it into either equation and solve for the other variable. So I have to find what x is now. So I take what I found for y and I go into either equation, whichever one you think looks easier, and I plug in y with what I found it to be. So I'm going to choose equation 2. That just looks a bit easier to me. So I'm going to plug y equals 5 into equation number 2. That's step 3. So equation number 2 is x plus 2y equals 2. But I know that y is 5. So I'm going to replace y with 5 like that. So I have x plus 10 now equals 2 when I multiply those. And then if I want to solve for x, again, I have to get x all by itself. So to do that, I can minus 10. So those go to 0. But I have to also be fair and do it to the other side. I have x all by itself on the left, and then 2 take away 10 is negative 8. And there we go. I have found my x value. So that means that if I were to draw these graphs, we would see the two graphs cross at that point. Okay, so now I'm going to go a little bit faster for these next two since I've really spelled out the steps for you in the first example. Okay, so I'm just going to zoom in a little bit here so it's closer. Okay, so remember, step 1 is to isolate either variable in either equation. Well, be smart here, because if you look at number 2, y is already isolated. So we've already had a variable isolated for us. So step 1 is already done. So I'm going to say it's done. Y is isolated in equation 2. Okay, so that's a free step. Okay, so step 2 is to take the equation that's isolated and plug it into the other one. Okay, so that's step 2. Whoops. So step 2 is plug y equals 5 minus 4x, that's our isolated equation, into the equation we haven't used yet, which is 1. Okay? So I'm going to do that right here. So I take equation 1, which is 2x minus 4y equals 7. But now, where I see a y, I replace it with what y is equal to, which is 5 minus 4x. So 2x minus 4, I open the bracket. Instead of y, I replace it with 5 minus 4x, close it up, equals 7. And now you have only x's left in the equation, which means you can solve for x. So I'm going to distribute that negative 4 into the bracket to get negative 20 plus 16x equals 7. I have 2x plus 16x. That gives me 18x minus 20 on the left-hand side equals 7. Again, I need to solve for x. Oops, sorry about that. So 18x minus 20 equals 7. I want to solve for x. So the first thing I'm going to do is get rid of that minus 20 by adding it to both sides so that that goes to 0, which gives me 18x equals 27. Okay, I'm not quite done. I have to divide off that 18 so that x is totally by itself. But just be careful here, because 27 over 18 doesn't divide nicely. But let's check if we can reduce it. And we can divide a 3 out from each one. So if I divide 3 from 27, I get 9. Oh, sorry. I can divide a 9 out from each one. If I can divide a 9 out from each one, I get a 3 at the top and then a 2 at the bottom. Or 3 divided by 2 is 1.5. Okay, so either one is fine. All right, and the final step is to take what you just found and plug it into either equation. So step 3, I'm going to take my x equals 1.5 and plug it into either equation to solve for the variable I'm missing, which is y. So I'm going to plug it into number 2. You can plug it into number 1 if you want. Y equals 5 minus 4x, but I know x is actually 1.5. So y equals 5 minus, well, 4 times 1.5 is 6. And then 5 minus 6 is negative 1. So there you go. That was pretty simple. So my solution, if I put it in a point coordinate form, my x value is 1.5 and my y value is negative 1.